Welcome back to another video lesson. This lesson will talk about converting measurement units, and it is lesson 4.5. Make sure you have that gold note sheet that I gave you in class as well as your note. Here we go. Your table of contents will need to be filled out for this lesson. We are going to be on page 46 and 47, and you can title it Conversions. Go ahead and fill that out. Now I want you to flip to the very back of your notebook. You should have a conversion chart, which is part of your reference sheet for 6th grade. And that is going to be something that I'm going to want you to refer to even in the lesson today, in the video, and tomorrow when we practice. I have what the conversions are in your notebook here. I also have another conversion chart that has some of the same information. I stuck it on the right-hand side of your note sheet. I want you to cut that out. We are going to be trimming this down to put on page 47, but this guy is going to be on the top of page 46. These two conversion charts you can use as reference. This one is not going to be available on a test, but the first one, the one in your back of your notebook, it will be. And I like this one because it has length, width, and capacity, which deals with liquid. So it breaks up the different kinds of units, gives you that review. Hopefully you remember from your past 5th grade converting between different units. That's what we're going to be doing, with a 6th grade twist with ratios in there as well. Go ahead and glue that up at the top of page 46, making sure you have plenty of room underneath, because we're going to do one more thing as a reference for you before we get started. And that is gallon guy. I love drawing gallon guy. I want you to be able to draw gallon guy as well. In case you don't have these reference sheets available, you can know how to convert in capacity and liquids between different units. So, to draw gallon guy, I want you to draw a giant G, filling up the entire space that you have on page 46. Once you have that giant G, we are going to draw 2 Q's in the top part of the G, as big as you can make them. And they kind of look like his eyes. And then I want you to make 2 other Q's at the bottom. Those stand for quarts. How many quarts in 1 gallon? 4. Then I'm going to pick up a different color. We're going to draw 2 P's for pints. P stands for pints. Make the top of the P, this rounded part, as big as you can so that you can fit other letters inside that P, and 2 go in each. So how many pints in 1 quart? There are 2 pints in a quart. How many pints in a gallon? You can count up the P's and get 8 right away. That's why I like gallon guy so much. Inside each P, you're going to draw 2 C's and make them as big as you can, because we are going to write something inside the C. So there are 2 cups in every pint. That makes 4 cups in a quart, 8 cups in 2 quarts, 16 cups in the entire gallon. The last piece we're going to add to gallon guy before we give him a body is in each C, we're going to write 8 FLOZ. That's called fluid ounces, different than regular ounces. In each cup there are 8 fluid ounces, so we're going to write that 16 times. In each C, we're going to write an 8, and then a fluid ounce. Now we can go ahead and give this guy a body. I'm going to draw a cape. He's like a super guy. And he's going to be running or flying, whichever way you want Gallon Guy to be, or Gallon Girl. I'll even call him GG on his cape. I like being able to draw this because it's easy to convert and go back and forth between the units when we're dealing with capacity. So Gallon Guy on page 46, and now we're ready for this other page that we're going to put on page 47. It's going to be a long, narrow strip, so you're going to need to trim that down. And then we're going to put it on the left-hand side of the page, giving us some room to do some examples on the other side. Finish up your Gallon Guy and then put your note sheet in page 47 and get ready for a couple of points before we start examples. So I know you've been converting before. When we're converting today, we're going to use something that's new for everybody. So here's a vocabulary word that I want to introduce you to. It's called dimensional analysis. Dimensional analysis is when you include units in fractions as you set it up. We're going to be using ratios to help us convert today. And if you remember, I always said words first. The topics of what we're dealing with are going to be different units of measurement. Instead of writing the words first, we're going to write them within the fraction, and that's called dimensional analysis. And there's a reason why we're going to. And let's go through the steps that we need to convert. These are basically the same between converting from small units to big units and big units to small units. You'll notice 2 boxes on your note sheet. The steps are pretty much the same. I did it twice just to help us practice what they are, and there's a little tweak for the second one. So when we're converting using ratios and dimensional analysis, we are going to write the measurement we are given to convert with the units. That's the dimensional analysis part. So this is the first thing you have to fill in. We're going to be given a measurement, 3 feet, 2 miles. So we're going to be given something that's large and then asked to convert it into something smaller. We're given 2 miles, we might be asked how many feet is that? A foot is smaller than a mile. The second thing we're going to do is multiply what we have, that measurement we're given, by the conversion ratio. And that's where our reference sheet comes in. You're going to have the conversion, how many feet in a mile, how many inches in a foot. Those conversions we can write as a ratio. And we're going to multiply the 2 together. The dimensional analysis, having those units written in, allows us to do this cool thing that's called divide out the common units. And you're going to see what that looks like when we do an example. So if any number or unit is in the numerator and denominator, they cancel out and become 1. 5 divided by 5 is 1. Same thing for units. If you have feet in the numerator and feet in the denominator, they can cancel out and become 1. 1 times something is always itself, so that's why it kind of disappears. The last thing we're going to do is after we cross out those common units, we're going to multiply. And we will be left with the unit that we want to convert to. So let's do an example, and this will all become a little bit clearer. Our first example is converting feet to inches. A foot is bigger than an inch. So the first thing we're going to do, I want you to write example 1, and I want you to write actually 20 feet equals blank inches. That's going to be our answer line. And then we're going to do some work underneath. I'm writing this right to the right of my steps so that I can follow them along as we go. So step 1, write the measurement that we're given. We know we have 20 feet. So that's what we're going to start with, 20 feet. You can use the abbreviation, that's fine. Then we're going to multiply this by a ratio. And if I look on my conversion sheet, I can see the relationship between these two units. How many inches in a foot? There are 12. We will put the 12 inches on the top and 1 foot on the bottom. It looks a lot like a unit rate with the 1 in the denominator. So there are 12 inches in 1 foot. The feet unit should be in the denominator, and this 20 feet, this feet unit is in the numerator. We can call this over 1. And so this foot is in the numerator, this foot is in the denominator. Dimensional analysis, where we're just writing the unit next to the number. We do that so that we can cross out this unit in the numerator and this unit in the denominator. We want to make sure we're writing our ratio so that the unit we want to disappear is in the denominator, so we can do this crossing out of common units. That's step 3. And now we're just left with inches. That's what we want to convert to. So after we divide out the common units, the last step is to just multiply the numbers that we have. So we have 20 times 12. I put them over 1 just to give you a sense that sometimes you're going to have fractions, and that's why we're going to be practicing this in the middle of chapter 4. We're going to practice multiplying fractions and mixed numbers at this point in the problem while we're converting. For this, it's just a straight multiplication. We have 240. Our inches was what was left, so our answer is 240. Essentially, we are multiplying by the 12. However, it's important that we are practicing this setup for when the numbers are not whole numbers, for when they're mixed numbers and when they're fractions. That's where we're going. Let's try another one before we go through examples that convert small units to big units. This will still be an example 2, where we're going from something that's a larger unit to something that's a smaller unit. Okay, on to example 2. Please write down the actual problem. 36 yards equals blank feet. And now we're going to practice those steps again, practicing dimensional analysis and crossing out common units. So we're going to start by just writing what we're given, 36 yards, and we're going to multiply by the conversion ratio, how many feet in a yard. We can use our reference sheet if we need, or we just might know it off the top of our head. And we want to make sure this unit will disappear, so we want it in the denominator of this ratio. So 1 yard equals 3 feet. That is dimensional analysis, making sure the units are in the fraction so that we can then cross out the common unit, which is yard. There's a yard in the numerator, a yard in the denominator. They go away. We're left with feet, which is what we want to convert to. Now we're just left with our numbers. This is another case where they're just whole numbers, so all we need to do is multiply, and we are left with 108 feet. Just a little preview, they will be mixed numbers and fractions. We're going to do some examples with those. I just want to get you the feel of these steps before we go on to the next portion. Now I'm going to go down to the second box in our notes where we're talking about converting from small units to large units. Same basic steps, but it's a little bit different in the setup. And the first thing, same as before, we're going to write the measurement we're given, whatever is in the problem or in the word problem with the units. That's the dimensional analysis part. And we're still going to need to multiply by our conversion ratio. We get that from our reference sheet. The only difference now is that we need to make sure that the units will cancel and do that common unit trick. We might have to flip our unit rate around so that the units will cancel out. And you might have a 1 in the numerator and not in the denominator. We're going to divide out common units just like before, and we're going to multiply and keep the unit that is left. But when we're doing this, because the 1 is in the numerator of the setup, we might end up having to divide in our math when we are trying to solve. And let me give you an example so that you can see what I mean by that. We're going to be doing example 3 right underneath. Please write down the original question. We're converting 15 quarts and finding out how many gallons that is. Just like before, we're going to start with what we're given. We know we have 15 quarts. Just like before, we're going to multiply by the ratio conversion, the conversion ratio, but we want to make sure this quart unit is in the denominator, and the gallons, what we're trying to find, is in the numerator. Now we can go to either our gallon guide or our conversion chart, find out how many quarts are in 1 gallon. Notice the 1 is in the numerator and the 4 is in the denominator. Before it was the other way around. Now we can still do our crossing out common unit trick, and we're left with gallons, which is what we want to convert to. So our math ends up being 15 over 1 times 1/4. This is where chapter 4 skills come into play when we're converting. We're going to multiply across and multiply across. We have to convert this into a mixed number because it is improper. So 15 divided by 4, we have 12, which is 4 times 3, and then we have 3 and 3/4 gallons, which is our answer. So that's example 3. Let's do another one. The more you do this, the more you'll get used to it. Our 4th example, we're going to be converting 3 cups, and we're going to figure out how many pints that is. Again, this is a small cup and a larger pint, so we're converting from small to big. We're going to start with what we are given, 3 cups, and we're going to multiply that by a conversion, but we want the cup on the denominator. So I'm setting up my units first. So the cups go on the denominator, the pint goes in the numerator because that's what I want to convert to. Now I need my conversion. How many cups are in a pint? There are 2 cups in 1 pint. Notice the 1 is in the numerator again. We can now cross out our common units, and we're left with pints, which is what we want to convert to, and we're left with 3 times half. We multiply that across, it's 3 over 2. If we divide, we're left with, so we have 1.5 pints is equal to 3 cups. Now, I did those 4 examples over on the right. Now I'm going to practice some word problems with you, and I'm going to do the work on the back. So you have that room as well to use as we talk about word problems. The only difference is that we have to just pull out the units that we need to convert between, and it's the same process. So 2 more examples with you, and then you'll have a couple to try on your own. Example 5, 6, 7, and 8 are all going to be word problems where you're just needing to pull out the units that you're converting between and do the same thing that we've done in our other examples. So Marco mixes 1/4 cup of fertilizer with soil before planting each bulb. How many fluid ounces of fertilizer does he use? So basically, we're going to be converting between fluid ounces and cups. So I'm going to write down 1/4 cup equals how many fluid ounces. Just like before, we're going to start with what we know. Notice this is a fraction, that's why it's a little different, but we're still going to need how many fluid ounces in 1 cup. There are 8 fluid ounces in 1 cup. Now we can cross out the common units and we're left with the unit that we want to convert to. Now we have the fraction 1/4 times 8. We put the whole number over 1 and we have 8/4, which when we divide is 2. So our answer is 2 fluid ounces if we have 1/4 of a cup of fertilizer. The last word problem I'm going to do with you deals with a mixed number. Again, just stepping up the complexity a little bit with it being not a whole number. So we have Mika needs 4.5 feet of fabric to make a costume for a play. How many yards of fabric does she need? We're pulling out the 2 units we're converting, and we are asked, we have 4.5 feet, how many yards is that? So this is going from small to big, but we're going to do the same steps. Start with what we're given, 4.5 feet, and we're going to multiply it by that ratio. We want the feet in the bottom denominator so we can cross them out, and we're left with yards. So 1 yard equals 3 feet. Notice the 1 is in the numerator now. We can cross out the common units, which is feet. We're left with yards. So now we are left with the numbers 4.5 times 1/3. This goes directly back to our other lessons we've been working on. So we're going to convert this to an improper fraction of 9/2 times 1/3. We can do that simplified trick, if you remember that, because 9 and 3 have a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So we're left with 3 times 1 and 2 times 1, which is 3/2. You know that automatically as being 1.5, or if you remember from our other example when we divided, we got 1.5, which means we have 1.5 yards. So here are 2 other examples that you can try on your own. The only difference is that it asks you to convert it to the nearest pound and nearest foot, which means when you are finding your answer, it's going to involve you either dividing, in both cases dividing, and you will get a whole number and a fraction part, and you just have to bump it up or down to the nearest whole number to answer the question. Go ahead and try those, and then you can go to the very end and I'll give you the answers so that you can check. I will not be doing them. However, if you have a question tomorrow in class, we can answer how I got to those answers. So at the very end of doing this problem, I ended up with 666 6/10, which I bumped up to 667. And for number 8, I got 2 with a remainder of 11. So that was the mixed number 2 and 11/12, which is close to 3. Those were your answers. I hope you got them. We'll practice more tomorrow. I'll see you then.